Good morning. How do you do?
Michael, good morning. Everything is going fine over here. What about you?
Doing very well myself. Yes, indeed.
Okay.
It's actually a holiday here, so um,
Oh,
got the day off, which means that I don't need to rush off to a stand up after our conversation today.
okay. Okay. Nice to hear that. No, here it's not a holiday, but
Mhm.
it has been relatively quiet today so far. I've
Yes.
I've I've seen that you made some nice documentation on GitHub. The
Yes.
README that was nice.
Yeah. I decided that the README seemed to be the appropriate place for the diagram, since that describes how the
Mm,
system works. Somebody would be, if they're going down that path, they would start by visiting
yeah.
the repository, and uh,
Hmm.
and so I think that I would like to start bringing Jinag.JS and Jinag.net into closer alignment, and so that document will probably live in both places. So it's kind of describing, as I bring Jinag.JS. Yeah, there are different classes that serve the same purposes in Jinag.js. So I'd like to kind of do some renaming, make them look a little bit more
Hmm.
consistent, so people can jump from
Yeah.
one to the other.
Yeah, if already the names are the same, that would be a lot easier, I
Mm-hmm.
think.
Yeah, yeah, I think so.
except except for the name the name factin.net.
Yeah.
No, but it's confusing. It's used in three places. It's used for the unit test.
Mm-hmm.
It's used as a real fact, and it's there is a third place where wait, I wrote it down somewhere.
Yeah, I think
Um,
it's what would in Jinag.js be called a fact record.
yeah,
I think I
and
used fact for that.
you have the instance runtime fact, you have the parameter fact, and you have the type fact.
Yeah.
Um, so it's a bit confusing, but okay. I've sent you a link. You already see it, I think. Eh?
Yes, indeed.
Okay,
Hold on.
because I've been watching the video from last time with the Cartesian products,
Mm-hmm.
and I still don't get there. So I got back to chapter 9 for the 10th time.
Mm-hmm.
Uh, start rereading, start taking notes, then put in some facts in the diagram, and try to document it for myself.
Mm-hmm.
And I'm wondering with the new renderer that you made, because this is still
Mm.
all manual. But I think the combination of the new renderer and then real practical examples, that would be much easier to understand for people like me.
Mm-hmm.
Um, there is
Okay.
you here, then there is the average population, and I'm here below. But
I don't think that's quite
no,
accurate, but yeah, I think we can do something
still
to
it's
make it
still
easier for
difficult.
everybody.
It's still difficult to catch up. Um, anyway, looking into the source code, is it correct that the inverter in the source code is still the step-by-step converter? It's not the Cartesian product.
The the one that's in JS definitely is the step-by-step one. The one that's in .NET is moving toward the Cartesian product one. So it's
because
yeah, it's
because
a lot closer.
because the inverter class is a very small class, very small.
Hmm.
But from what I saw, it's still working through the steps. So I didn't really go into detail, but I didn't saw the Cartesian product. But I think the combination of your renderer and then the pipeline inverter with Cartesian products, I think we can really work out some nice documentation there
Mm-hmm.
with examples how it works. So I started something here with an example from the book,
Mm-hmm.
but just for myself to start understanding. So I went back to that restaurant example,
Mm-hmm.
the server, the table assignment, then the seat party, which assigns a party, some people to the table.
Mm-hmm.
So that I say, okay, we assign a set as servers, Tim, Russell, David. We have 9 tables, and we have some presidents, some
Uh-huh.
prime ministers with their family who come and eat something.
Uh-huh.
And then seat party, so the table name, and then, for example, Joe Biden, Macron, and Boris Johnson.
Mm-hmm.
Yeah. So just a small data set to see what happens. If then, so each server has its own view UI of his tables, and a table is really a table, a
Yeah.
restaurant table.
Yes.
Yeah. Perhaps I should restaurant table, yeah,
Mm-hmm.
of his restaurant tables and his parties to be served. So each server runs the same query. So whether it's Tim, David, or Russell, each of them runs the same query, but with a different start effect, and the start effect is his own identity.
Right.
That's correct.
Mm-hmm.
So the query, using the syntax from the book, it's a literal copy from the book. Parties assigned to the server. So these parties assigned to a particular server match the assignment where the assignment.server is the server, and then take the seat parties where seat party.table is seat party.party.
Mm-hmm.
Is assignment.table here. Is that then seat party dot? Yeah.
Mm-hmm.
Okay. And then what I find a little bit confusing in the book is that here we don't say, for example, so here select, in this case, sp dot party.
Yeah. Yeah.
So that
So
projection.
yeah, the factual modeling language as it had evolved by the time of the book didn't have any kind of a select mechanism. It didn't have projections built into the queries. So it was basically the last thing that and I hadn't come up with the Cartesian product thing. Otherwise, it would be all of the things A and SP that product. But the idea was the result of that query was the seat party. So yeah. To make a bit more sense, then yeah, you're right. There probably should be a third line. The syntax for it would be a little bit different, but essentially what you're talking about there. Select the party. I think maybe the reason I didn't do that in context is that when I used that query, perhaps it was in an annotated view. I was using the seat party fact and then getting access to both the party and the table. And so and that also is pretty important when it comes to taking the next action. So you're interested in the seat party fact, not just the party itself, so that you can then continue that conversation and say, okay, this party having been seated has now left. So that would be a successor to seat party. And if you have thrown that away and now you just have access to party, then you would have to somehow get back to it. So I think
Yeah.
that's what was going on there.
Because just for the understanding of somebody who reads it,
Mm-hmm.
I think it would be nice just to add that.
Mm-hmm.
Um, yeah, people start calling me. They will have to wait. I just leave it in here. Now, this is
Mm-hmm.
just some documentation for myself.
Yeah. Yeah.
Perhaps in the end we can. I did it in this Excalibur, but perhaps we can in the end make an markdown file from it and use it somewhere in documentation.
Mm-hmm.
But I think it's still too early for that. So then we have the UI of every server, and we see, yeah. So in this example, we see Tim. He has assigned tables 1 and 3,
Mm-hmm.
and tables 1 and 3. Table 1 is Joe Biden, and table 3 is empty.
Mm-hmm.
Russell 6 and 9, 6 empty, 9 Boris Johnson, and David, he just came in, he has no tables assigned, and so no parties seated. Then, as new facts come in, we want to know, 1, whose UI has to be updated, and 2, how should the UI be updated? That means what should be added and what should be removed.
Right.
Now, the only facts that can influence the UIs are the assignment facts and the seed party facts. And that are the valley facts. So the reason facts are processed in chronological order. And the new table fact or a new party fact cannot have a successor yet.
Mm-hmm.
This means that the new table cannot not be assigned to a server yet, and the new party cannot be seated yet.
Right.
And then we come up with the... Still not used to this. So imagine an assignment is added. So we add David, the assignment fact David, table 2. So to find the tables and the parties to be added to the UI of the UI affected server, we rerun part of the original forward query. So parties added. We have a new assignment, David table 2. We look for the seed parties, and we select the table and the party. The table goes here, the party goes there, but we still don't know who is the server, so whose user interface is affected.
Right.
So if the result of this previous query is not empty, then we need to find the affected server. And we can do this by running the following inverted query. So here it's an inverted query. Service to notify. We match from the assignment to the server, and we select that server, and that's David.
Yes. Yes. So yeah, it looks like you you took the pipeline with the inversion, and then you turned it back into factual here.
Yeah.
Yeah. Cool. That makes it really easy to understand.
And so here I started with a forward query and then the inverted query, because that makes it clear if the original query is empty, then we don't need to do this inversion anymore.
Right. Yes.
And then same thing for seed party table 6 with Putin. So yeah, the seed party. So it's very easy to find the party, which is Putin. And then we need to find the servers that are to be notified. And that turns out to be Russell. Yeah. What I forgot here is the table. I didn't put a select in here.
Select the table.
So then here, select. So there we had the seed party. Here we had to select the table.
A dot table. Yep.
Yeah. A dot table. So.
But actually, I'm sorry. Yeah, the Yeah, not the table. It's the server that you're looking for. That's the affected one, and actually that you're then.
Oh,
Yeah, that's
yeah.
probably.
I'm looking for the server.
Yeah,
Yeah.
yeah. You probably
So
just intended to write
that's
select instead of then for that
yeah.
second line.
That's why I didn't put in a select, but in
Mm-hmm.
fact we can put it here also. So
Yeah,
an
which
a dot server select a dot server.
which
Yeah, it's
honestly, with the version of factual that's in the book, then a dot server is is the correct way because it was just take the last result, and so yeah, that makes sense.
all right. So this is just with some data.
Mm-hmm.
But now, if we want to do this inversion, for example, if we want to find this inverted query with the Cartesian product, yeah.
Mm-hmm.
So we have added a seed party. So if I go back to this one
Mm-hmm.
here, so here we added 6-VP to this set.
Mm-hmm.
So we have 3 elements in this set. We have 4 elements now in that set.
Mm-hmm.
We have 6 elements here. So how can just making these Cartesian products give us the result? Because what we are looking for is just the tuples that that are validated by the queries.
Right. Yes.
So if we have the whole set of all these tuples, how do we know which tuple is going to be the correct one?
Yeah. So the way you figure that out is right here in the query. You've given a label to 2 of those facts. So A assignment and SP seat party. So
Yeah.
so these are both labels, and so that means that that these 2 are the are the elements of the tuple. So
Yeah.
so that means let's go ahead and I'm gonna drop some text over here so we can say that we've got A colon assignment and SP seat party are the 2 elements of the tuple, and so with this particular data set, the tuples that are consistent are Tim1 as the assignment and 1JB, and then Russell. My best friend's name is Russell, and I always spell it with 2 L's. 6 and 6VP. Those 2 are consistent, and then Russell
and 9 and BJ.
Yeah. Yep. So yeah, that means that that these are all of the consistent pairs, and so if you are so actually in the there's one other thing that we need to add to this. The starting point is part of that that set. So we've also labeled S server, and now I'm wishing that I had used a different mechanism here, but so
you can use stamp in it, I think.
You can use what? Sorry.
A tap function.
Yeah,
Tab key.
Oh,
Yeah,
okay, yeah. Okay, and
it's
then
slightly easier.
Russell here and Russell here. Oh, that's weird. Okay, so so you've got these three tools because those are the three things that you've labeled. And actually, now that I look even more closely, this select labels an element as well. Now, those are all based on predecessor relationships, so they don't actually blow out the diagram. But one thing that'll happen in Jinag.JS or in Jinag.net is it will take this this role name party, and it will turn that into the name of the label. So it'll actually call it that if that's the text that you've got. And so now we've got JB, and we've got VP, and we've got BJ.
Yeah.
And so now you've got these tuples that have 4 elements in them, and they are all mutually consistent. So running the query means constraining these tuples to a given server. So when Tim runs the query, he gets back this one result. When Russell runs the query, now that we've got 6VP in there, he gets back these 2 results.
Yeah.
So that's the forward way of doing it. Now, if we wanted to invert it, because we just added a seat party, now we are running the query, but we're keeping seat party fixed, and we're no longer keeping server fixed. So because we just added 6VP, we run the query keeping 6VP pinned as the seat party, and we get back this one result. So now we say, oh, I need to notify Russell that Vladimir Putin has just sat down on one of his tables. And so,
yeah, but
so that's what an inverse looks like.
Yeah, but you don't know that second here, that second tuple, that one, you don't know yet at the moment that you have to run that inverse, because that line was added at the moment that we added the seed party 6VP.
Mm-hmm. Yeah.
And at that moment we only had the first and the third line, not the second.
Yeah, so let's separate that in time. So yeah, we ran the query the first time as Russell and got back this one result.
Yeah.
But when Russell ran that query, he didn't just do j.query, he did j.watch. So now he is he's looking for any new changes. So so that's the first one that he gets back. But then when the seat party fact is created, then it runs the inverse. And looking at it as a Cartesian product, the inverse is exactly the same as the original query, except you've chosen a different starting point. So you're no longer running the query starting at server, you're running the query starting at the fact that was just added. So at that point, we added the 6VP, and then we run the query, and so now we end up with this consistent set.
Michael, you have 6VP, and then which query do you run then?
Yeah, so the version that looks like it looks like this. So it's
wait, where are you?
Oh, I'm sorry.
Screen?
Yeah, I scrolled down to yes.
Okay, I see it. I see.
Okay. Yep. So so yeah, this pair of queries, it's looking for the affected set, and it's looking for the added set. So affected is the servers to notify, added is the parties added.
Yeah.
But when you're thinking about this as Cartesian products, then it's no longer two separate queries. That's the beauty of it. It's still the same set of relationships, and so you're still looking for a set of tuples that are mutually consistent, and you're just fixing one as a
Does
tuple.
that mean that to make this query here, you can see my cursor, I think.
Yes.
So the service to notify, that's the inverted query. In fact, that one is still made in the traditional way by inverting the steps.
Correct. Yes.
The purpose of the Cartesian product is not to make this query.
Yeah. The purpose of the Cartesian product is to really simplify the the math and the logic behind what the query or what the inverse means. So yeah, rather than thinking of the query as a sequence of instructions, you think of it as a set of relations, and those relations are true whichever direction you take them in.
Okay, but so to generate this query, there is no change in the way we generate that query, that inverse query.
Right. If you're talking about the relations, then you're correct. There's no difference between the original and the inverse. It's the same relations. If you're talking about the sequence of steps, which is what the computer will ultimately need in order to execute that query or that inverse, then there is a difference. So if we come back up to the top here, and so I'm going to create some other text down here where we're going to talk about the relations. So rather than looking at it using factual, we'll just talk about the relations that we've got a S server. That's my original starting point. And then, well, let's just say that I've got, I'm not even going to identify what are the starting points. I'm just going to say this is the set of all labels. So I've got these 4 labels, and then I've got these relationships. So which I can just copy straight out of there. I can say a dot server equals S. So that's an equation that has to be true. And sp.table is equal to a.table. So that's also an equation that needs to be true. And then this last one here kind of infers sp. That's that relation there.
Yeah.
So so I have these 3 relations, or 3 equations, 4 unknowns, if you want to think of it that way. So that means I've got 1 degree of freedom in this system of equations. And so I would just want to satisfy all 3 equations, and because I've got 1 degree of freedom, I need to pick one thing in order to get it constrained, so where it makes sense. So when I first run the query, I pick the server, and then you basically do the algebra. You just rearrange these equations so that the server is server is on the right, like it is here, and now we can find all of the assignments that satisfy that. And then, having the assignments, put that on the right, find all of the seat parties that satisfy that. And then put seat party on the right and find all the parties that satisfy that. So it's already in the right order for that kind of query. So if I want to compute the inverse, then I'm basically just going to rewrite these equations. So let's compute the inverse from the perspective of seat party. So that means I need to put seat party on the right. So I'm going to have that one there. And I'm also going to have a.table equals sp.table. So I'll take this second one and I'll flip it so that seat party is on the right. And now I've got table on the left, or a on the left. So
I will, server.
Yeah, so I'll take that top
server
one.
Is a server.
Right.
Yeah.
Yep. So now, even though I haven't actually changed the system, I've just rewritten the equations that are part of that system. I have rearranged it to make it easier for the computer to step through one step at a time. So given a seat party, it can find the party, and it can find the assignments, and it can find the servers.
Yeah.
And so then it can follow those steps once 6-VP has been added to the system. And when it follows those steps, it finds VP as the party, and then it follows these two paths, and it ends up with Russell as the server. And passing through, it finds that A is equal to Russell-6.
Okay. Yeah. So and so actually the Cartesian product is just a different way of looking at it.
Mm-hmm. Yep.
Okay.
Yeah, PF Cod was onto something.
No, I thought it was some easier way to inverse the queries, because this is a simple one. But if you have conditional filters here, then it becomes more complicated.
Yes, it
so
does.
You still go through it step by step.
Mm-hmm.
You just inverse the steps. That's all. All right. And I was just looking too far.
Yeah, and that's part of the reason that you'll see that the inverter is a really small class, because the data structure is already set up to support this. The data structure is just a collection of paths, and each path is just a single equation. It's just a relation. And it knows what's on the left-hand side and what's on the right-hand side, because it's got a sequence of successor steps, or predecessor steps, and a sequence of successor steps. And so starting at S, I can find all of my A's by taking a successor step along the server role. So starting at the server, follow my successor along the server role to the assignments. And so that's just expressed as a path with no predecessor steps, one successor step, leading to assignment as the result. And then it just has that collection of paths organized by their labels, where they end on. And so now you can just quickly iterate through those paths and apply them to a data model in order to run the query.
Okay. I think now I can try to understand the inverter class. It should be a lot easier.
Yep. Yeah.
Anyway, the class is a lot shorter than I thought it would be. It's quite condensed. Okay, but then I will try to still extend a little bit this documentation. When I start playing with the renderer, just to get some practical feeling, because that combines then the syntax for the specifications, for the queries, the use of the renderer, facts and types. I think we can make something nice out of that.
Yeah, and in fact, I think with the renderer as it currently is, you should definitely be able to draw this diagram. And I'm also thinking that you'll be able to put in these specific facts, and then you should be able to run dot invert or inverses. Yeah, so you take your specification and then dot pipeline, and you got your pipeline out of it, and then you should be able to say dot inverses and get basically get these two inverses out of it. So you should be able to render those out, see what they or just to descriptor string, show what the text is, get something kind of like this out for that text, and then you should actually be able to use j.query. You can't do j.query directly on a pipeline. You need a specification for that. Yeah. So I was hoping that you would be able to actually execute those inverses and see the results, but no, you won't be able to do that.
Why are we not able to do that? Because
it's j.query.
It's a pipeline. Oh.
Yeah, j.query is intended to run on a specification, and the first thing it does is turns it into a pipeline, and then it actually executes it. The inverses are pipelines, but not specifications. So it's just the way that the API is designed. It's intended to start from what the user would write, not from what the system would generate.
But mathematically, we could a pipeline turn it back into a specification.
Yeah, that would be possible. In fact, really all of the specification is in the code is a class that has a pipeline and a projection, and it knows the C# classes that it came from. So yeah, there's it would be pretty easy to write a function that turned a pipeline and a projection back into a specification. Or in fact, you could just make an assumption about the projection. So given it just a pipeline. Yeah. That would be possible, but that's not in the library right now. So you would have to do that extra bit of work, and then you could actually run your inverses.
But let me think about it. That makes me understand how it works. Good. I'm gonna save this one, that we don't lose that. Then I had another question. Actually, when I tried to rebase one of the branches, just a very early starting branch that I made on one of your early commits, I want to rebase it, and it gives me a lot of merging trouble on the solution file. Now, what I see is that your version still has version 15, which corresponds to Visual Studio 2017.
Oh, that's
And are you working on a Mac or on a PC, on Windows?
I'm going back and forth, but I'm not using Visual Studio for Mac. I'm using Visual Studio Code, which is capable of opening. Yeah, it is capable of opening and editing a solution file. So I wonder if it uses the 2017 format rather than 2019. Because yeah, when I'm working on it on Windows, I've got 2019.
Okay. Because if you go and look into the solution file, it says version 15. And apparently, because on Stack Overflow, I found that actually the solution file is using GUIDs for different project types. And apparently there have for a couple of years been bugs where it changes that GUID by another GUID the moment that you make a new project. And as I added a new project for the SQLite store, and you added a new project for, I think, for the renderer, so it messes up everything.
Yeah, I have seen that before. And what I think what I usually just end up doing is accept all of. Usually, I'll accept all of the other person's changes because I know exactly what I did. Open it up in Visual Studio again, and then just re-add that project. So that might be what you need to do.
Perhaps the easiest way. No.
Yeah,
anyway, I didn't do a lot, so it's easy to re-add it. Okay. Why do you have two different projects, a Jinaga.unit-test and a Jinaga.test?
Yeah. Again, naming is hard. So unit test is supporting unit testing, and so that's intended to be published. .test was my own unit tests. So the unit tests for Jinaga itself, and so that's not intended to be published as part of the NuGet package.
Okay, so that's why the memory store is in the unit test.
Right. Yes.
All right. And then what else did I write here? Okay, why for Jinaga you did not enable the .NET analyzers, which you did for, I think, the unit test project.
Okay, yeah, that was not a deliberate decision. So, yeah.
Was that because .NET 5 and .NET Standard 2.1? Because if you add .NET 5, I think it is installed automatically.
Okay, that might be it.
And if you start a project on .NET Standard 2.1, you have to activate it manually.
Okay.
No, these were just small things that I saw, and I say, why?
Yeah.
Perhaps there was no real.
Now I believe that, and I can actually take a look at the project files to confirm. I believe that the idea is that Jinaga is a .NET Standard 2.1 project. Yeah, that's .NET Standard 2.1.
Yeah.
So that you can use it in any kind of modern .NET application. And Jinaga.test, because it's not one that you would take a dependency on, that is actually .NET 5.
Yeah, I think it is that way.
Yep. Yeah, and so Jinaga unit test should also be .NET Standard. That one, unit test is targeting .NET 5. Interesting. I wonder if that might cause trouble to somebody down the road, and maybe Jinaga unit test needs to be .NET Standard 2.1 as well.
Now there's 2.1. Is 5. Or perhaps in the future, both of them .NET 5.
Yeah, I want to. I don't want to force people to upgrade the framework that they're building on. If they wanted to add Jinaga to an existing project, they should be able to do that as far back as 2.1 can support. Yeah, I don't think that using anything in the Jinaga core library that would require a certain framework version. Now with like for example, adding bindings to Xamarin, that would lock you down to a certain framework version, or perhaps accessing a certain data store based on the binaries that are available for that data store, the drivers. Then that makes sense. But then each one of those DLLs can be independently cordoned off so that they take those dependencies, and the core library is able to be as generic as possible. So I think the unit test support library should be as generic as possible as well.
Should also be in 2.1 then.
Yeah.
Okay. Good. I have no more questions.
Okay. Well, I have some things to share. So let me get the screen sharing thing going. All right. So are you seeing VS Code?
No, I'm seeing the infinite screen.
And okay.
Audio as well.
Yep, I clicked on the wrong thing again. There we go.
Yeah, now it's okay.
Yeah, screen should be the first one. You have to switch to the screen tab. Okay, so I was working on projections, and I think I'm getting close to what I want the projections to look like. So put together this really small model here of a family, a person as a member of a family, and then the person's name using the mutable property pattern there.
Mm-hmm.
So I've got this condition on that property is current, so there does not exist any fact of type person name where called next, where next prior contains this. So the mutable property pattern. One minor thing to point out here is that as a convenience, I made it possible to combine the where clause that immediately follows of type, and actually just put that that predicate directly into the of type. So that's I'm always doing of type dot where, so it's like let's shorten that up. I mean it's following the same pattern that you see with dot any. You could put a where clause in there in standard link, that kind of stuff. So okay, so we've got that model, and so what I want to do is be able to get the list of members of the family and their name. And so in order to support that, I created this specification for the names of a person. So given a person, match facts of type person name, where name is the name of that person, and then dot where, so apply the condition, the name is current. So that applies that condition. So that filters out anything that has been superseded by a next person name. Okay, so we've got the Perry family here, and
I'm back.
okay, excellent. I should probably add a little stream timer, like 45 minutes, and then it's going to happen. So we've got the Perry family here, and so I want to do a j.watch. So this is, well, before I get to watch, let me create a new little section down there to hold on to that stuff. So before I get to watch, let me do a JDAT query. So the the people is await JDAT query the Perry family, and then I want to do a specification. So let's actually write this specification as a separate thing. People in family is given a family match these facts. So facts of type person or person dot family is equal to family, and that's it. That's well, that's not quite it. Yeah. So we're talking about projections here. So I can say what I want to do is select not just the person, but I want to. Here, let me spell it out so that I don't get confused. So we're going to create a new object that has the person themselves, but then also I will call it names because it can there can always be multiple. I'm going to say facts.all from this person, names of person. So now when I JDAT query people in family, then
so
what I
get
end up
the
with,
list of his current name and all his previous names.
Since it's got this condition is current, it'll just be the current name, not all the previous ones. But it will also include simultaneous edits. So it'll include concurrent edits. So all current names, all names that could be current. So actually, I haven't added any facts. So got it not implemented. Okay, that's all right. I'm not going to be able to show the actual people in that query anyway. But the thing is, if I take a look at if I take a look at person, I've got the actual person object there, and I've got names. So yeah, person, as you might expect, is the person fact. So we've got family, we've got birth date. So that's all the fact stuff. But then also in here I've got names, and that is an enumerable thing. So I could say, select, and then what that has, that is an actual fact. So we can see we've got is current, person, prior, value. So that's an actual person name fact. Yep. So when I use facts.all inside of j.query, I get back that collection of names. So that's and that's as far as I want to take projections, because now you've got a unit of composition. So names of person can have its own projection in there, and so what you get back here is a collection of whatever its projection is. And so you can build these things up.
Mm-hmm.
So where SQL has a whole bunch of aggregate functions, and you can select different fields of the different columns of the tables. I'm saying none of that. All you can do for a projection is either just the stream of facts themselves, like you're getting out of this, you're getting the person names, or it can be a stream of composites. So you've got this object that's got two properties, and so you're getting a stream of those. This tick A is this anonymous type, and then that composite, each of the fields is either a fact, a composite, or a collection. So in this case, names ends up as an observable collection.
Mm-hmm.
And so that gives you a way to compose any kind of data structure that you would need. But I'm not going to give you the aggregate functions or sorting capabilities or anything like that. You have to do that with the results that you end up with.
Yeah. The reason that you don't build it in is because it's not efficient in the query language?
Yes, and because the things that I would end up doing with the projection, the more complexity I add to the projection, I have to add a lot more complexity to each of those downstream things. Like, for example, using these in inverses. If I basically with this limited type of projection, I can identify which tuples it is we're talking about. So so this query gives you a in fact, I can show you what the query gives you. So let me.
Because the moment you add aggregates, you don't find the originals back.
So we can say here's the pipeline to descriptive string.
Mm-hmm.
So that one is the not implemented exception comes in with actual building of it. So the parser is just strong enough to work inside of a unit test, but apparently this is doing something a little bit different outside the unit test. Okay, well, what I wanted to show, actually I can show in the unit test itself. So let's go to Jinag.test. We've got our projection test here. So right here, when I do a projection here, facts.all, names of passenger in this case, I end up with names is equal to the array, the collection of passenger name, and passenger is the passenger. So there's the pipeline. So that's the set of equations that relate passenger to airline, which is the starting point here, to passenger name. So that 3-tuple. So given an airline, it find all of the passenger name pairs that are mutually consistent, and so it's going to take all the distinct passengers and give you one result here, but then group all of the passenger names that are consistent with that passenger and give you that collection as the names. So you can see how to just take a set of tuples, group by the things that are the same, and then give you those collections. I mean, that's an operation in the relational algebra, and one that has survived into SQL. In LINQ, that's the group by operator. In SQL, group by is only used for aggregates. But actually, yeah, one of the aggregates gives you a concatenated string. But anyway, yeah, so this aggregates by all the distinct things that are in that projection, and then gives you all of the tuples that match that projection. So,
Okay.
I mean, that's all the very general mathematical way of saying it. What this is going to end up doing is to give you one result in people for every distinct person in the family, and then each one is going to have a collection of names that has each distinct possible name for that person.
All the names that are current then.
Yeah. Yeah, and so then it would be up to you to say, okay, I want to pick one of them to display to the user, because if I show the user all possible names, they get confused. So, so then I have to put in an order by in order to say which one is my preferred one, and then do a first or default on that collection. So, so all of that happens after the query, and you just have all of the candidates to work with. And so that's query, but J.watch ends up being something different. So what we can do is so J.watch, starting at the family, we want people in family, and now here the parameter that I end up with is this third parameter here, an action to perform on that projection whenever it's added. So, so like that's what this code down here is kind of getting into. In fact, let's just drop that and look at this code instead. So, so we're going to, yeah, that is just people in family. Yeah, it's not compiling anymore because of that error up there. But this is what I was starting with. So you remember I had the onAdded, onRemoved, and there was another one onModified. And as I got into taking a look at what these things are actually doing, that didn't quite work out. In fact, let me put this up here. Maybe it'll, yeah, it's starting to at least give me IntelliSense, so it knows what these types are, even if it can't run the code. And so, so I've taken out this observation with onAdded, onRemove stuff. So the first thing that I discovered is that onModified didn't really make sense, because you could have as many of these collections inside of your projection as you want to, and they could be nested. So what you're really after is what actually changed, which one of these collections was affected, and was something added to the collection or was it removed from the collection, and take that all the way down. So one blanket onModified at the top just didn't make sense. And so so I started down the path of, what does make sense. So we've got the names here, and so that's my observable collection. It's not going to be able to tell that because of this error up here. And then I can further say onAdded to that observable collection, do something, and onRemoved, do something else. And then I can set up all of those responses inside of this this top level lambda here.
Okay, yeah.
And so that allows me to keep on going as far down the tree as I need to, because inside of here, I'll have this this name here is actually one of these names of person, so it's actually coming from here. This could have its own projection with its own collections, and I can do unadded inside of here, and I can just keep nesting those. But then I started noticing that when I want to take this person ID and use it inside of this onAdded, I'm doing that because of a closure. It's taking this variable that's declared outside of the lambda and using it inside of the lambda. So closures are a really powerful composition mechanism in C# or in any functional programming language. But then here I'm returning it so that I can use it here. So on the one hand, in order to go deeper into the tree, I'm using a closure, but on the other hand, in order to remove, I'm returning it so that onRemoved can take it. And I thought that was just unbalanced. So so I went with something different, and so what I ended up with was, let's take this this whole async result out here. We call this, but then what we return is this operation here. So we no longer have this onRemoved. Yeah, it's a little bit easier to read like that. So so now we're using closure for both of these. So we're taking whatever information I need, closing over that in order to produce this new lambda here.
Yeah. Why do you prefer this syntax compared to a separate unadded and unremoved?
A number of reasons. One is that it's more consistent with the way that you would go deeper into the tree. Another is that there are no longer any constraints on the type. So if you've got perhaps several different variables that you need to use as closures inside of here, if you need to return it, you would need to return that as a tuple and then take it back in as a tuple and then destructure it and start using it. So so it was a little bit it added that constraint. I had further, even though I didn't really need to in the end, I had further constrained that value that it was returning to be a value type. So it had to be the struct generic constraint. I was thinking about that because of journaling, but then I realized, okay, journaling is going to be a separate thing, so we'll put that on hold. And so things like if you're using this for a user interface, you might want this to be to add something to a list, and you might get back a UI component, and then here you remove that UI component. And so that's not going to be a value type. That's going to be an actual component. So this kind of frees up the user to do whatever they want with the types. But then the other thing is that with the unadded, unremoved syntax, you don't have to call unadded on anything. Well, actually, no, I solved that with the type system too. It wouldn't compile until you do a non-added because it returns a new type. So it's, but I did make it possible to call unadded a second time, and so you could have unadded, you do this, and then unremoved from that, and you can have multiple unremoved, and then you go back to unadded something else, unremoved another thing, and while that was powerful, it also was unnecessary. All of the things that you would want to do when you add a result, you can do inside of one body. So yeah, it basically turns it into, okay, you get one unadded, you have to specify one unadded, and then as the response from that, you get one unremoved. As it turns out, you don't have to specify the one unremoved. I made it convenient not to, but so everything that you need to do inside of that removal, you do inside of here. Everything you need to do in the addition, you do up there. So yeah, it just in the end matched the semantics a little bit better, I think.
Okay.
So I took inspiration from React, by the way. If you've gotten a chance to play with React's on if or use effect hook, it's got a similar kind of pattern where when it first calls that effect, and use effect is for side effects. So when it first calls that use effect, then that use effect is allowed to return a function that takes no parameters, and then when it cleans up, either because it's just cleaning up the component or because the state has changed and it needs to invoke the effect again, then it's going to just call that lambda before it does that. So it's a similar pattern here, but it does take a little bit of functional thinking in order to get used to that. So it is a little bit odd.
It takes two brains.
Yeah, here it's okay. I haven't yet added the yeah. So this unadded here. I've got some overloads here. You can see that when I took a look at all the overloads, I get 4 of them, and they're for different ways of having this callback function, different ways of responding to the new fact.
Mm-hmm.
And so I allow all 4 of them for convenience, even though one of them is the most general. And I could just force you to use the most general, but then you have a lot of boilerplate. So the simplest is you just have an action. So you don't return anything. And then the next one is that you have a function that takes your projection and then returns the action. So so you take your result and then you return the lambda that performs the removal. And both of those are synchronous in nature. But then you've got the version that is an asynchronous action. So a function taking a projection, returning a task. But that's just a bare task. It's not a task of t. That is equivalent to an async function that just doesn't return anything, because implicitly it returns a task. And then here's the most general one, which is the one that we're using here. So asynchronous function, because it returns a task of t, and the thing that it returns is an asynchronous function, a function returning a task.
Yeah.
So I decided to go ahead and make it so that you could very easily write synchronous or asynchronous code inside of here. So you would do something synchronous if you were updating a user interface. You would do something asynchronous if you were posting a message to a queue or updating a database, like this example is trying to show. So this version of onAdded is trying to use this one, where I'm just giving it a function that takes the projection, in this case the person name, and returns a task. But I haven't added those overloads yet to onAdded here, so we'll write all of the boilerplate to make this work. So actually, I have to return an async function that does nothing. Or I could write this as return a function that returns task.completed task. So that would just be the boilerplate that you have to write every time if I didn't have all of those overloads. But when I get those same overloads here, then everything's going to be good. So yeah, that's what I'm thinking of for the watch syntax. It's actually pretty close to the Jinag.JS watch syntax. Except Jinag.JS doesn't have the promise version of it, so I need to expand that.
If the two grow a little bit in the same direction, that's going to make it easier.
Yeah, definitely.
There's already the fact that sometimes when you think into .NET with the records, and then you go back to JS to define a specification, just the syntax that is different is sometimes weird.
Yeah. I mean, I absolutely love being able to do this. I wish I could do this in JavaScript. But a JavaScript fact is a much longer thing. But then
Michael,
is
the reason for you to maintain that fact type separately from the name of the fact is that to be able to split it up in organizational units, to have a kind of namespace?
The fact type separate from...
Yeah, if you go back to that to the definition of the record. Yeah, so you have, for example, here the record as a name family, but you also give it a fact type nested.family.
Yes.
Do we really need that fact type? We could use the name of the record, I think.
Yeah.
But then if you want to have dotted names, it becomes quite strange and quite funny, I think.
Yeah. So yeah, like this one right here is one that you're identifying as a problem, and I just do that by convention that when I've got a mutable property of an entity, I'll use the dotted name notation. But it doesn't have to be that way. I mean, it literally could be this, and then if these records were in a namespace called nested, then that would exactly match the names of these classes. The reason that I don't do that, well, there's a couple of reasons. One is compatibility with Jinag.JS, and in general with any runtime, any Jinaga runtime. I want you to be able to make decisions about the model without knowing how you're going to implement that model yet. So if you decide, hey, I'm not going to call this person.name, I'm going to call it person name, because I know that I'm going to end up writing it in C#, then you're letting some of that implementation thinking sneak into the model, and want to discourage you from doing that right off the bat. So so that way, that's one of the reasons that it's not even going to try. It's not even going to use reflection to figure out the fact type. And so I actually could write a C# fact declaration for a model that I already have working in JavaScript. In fact, this is one of my exercises that I'm going to start on today, is write a C# declaration for the Improving You application that's already running in JavaScript, and then use C# to query the JavaScript generated model. So that's gonna test that out. But then there's actually another reason for having the fact type separate from the class type, and that is structural versioning. So if I later come to realize that hey, this model is wrong, I just had twins in the family, or maybe they weren't actually born to the same mother, but within the same family, two different mothers happen to have children at the same time. So it's like, okay, this is not enough to differentiate them. Then I should be able to come in and say, I'm going to have right now I'll just say person v2, and maybe add a birth order to that. And so now both of these are the same fact type. But when you take a look at the fields, I should be able to tell from just looking at the fields, this one's got a birth date, that one's got a birth date and a birth order. So structural versioning tells me which of these two C# classes that JavaScript object maps to. And so the relationship nested person, or that type, whenever I use it inside of, no matter which of those two classes I happen to use inside of the specification, at runtime, that is just going to represent this fact type. So so either one of them will match. But then when it gets to actually deserializing this and saying, okay, well, I've chosen a specific C# type, so therefore I've chosen a specific structural version, then it's going to further filter it just to that particular structural version. So that allows me to evolve the model and continue to run queries with the old version or the new version.
Mm-hmm. Okay. I didn't think about that.
Yeah, that was it's one of those, well, what about kind of things. It's. I remember on this very channel we had a long discussion when we were doing the book review about versioning and about evolving a model. So it's like, there are like 3 different strategies that you would employ, gradually getting more and more complicated. This is like version level 2 there, complexity, where you're adding to the model but just adding new structure to the existing model and using the same names.
Yeah, it's getting there step by step.
Yes, indeed. Yeah, I'm a little bit sad that this isn't working right here inside of the notebook.
You will be able to fix it.
Yeah. yeah, probably within the next 2 hours it'll be like, oh yeah, there it is. Fix that.
Good. I'm getting in some mails here of a customer who's having trouble. So I think I'm gonna have to call my customer.
Very good. Well,
I guess he just has to restart his software. had a little DNS problem this morning, and for some of the customers, it helped it by just fixing it on my side. But apparently, some caching is giving troubles for some of the customers. So
Yep, that's
I
one
will
of
have
the
to
two
call
hard
them.
problems, isn't it?
Yeah. Okay. Next week, Monday, Michael?
Yes, indeed. Next Monday,
Okay.
same time.
Okay. This week I will have some time. After next week, Monday, I'm going to Belgium for a week.
Oh,
So
nice.
that week I will not. But I'm leaving on Tuesday morning. So I will still be here on Monday.
Okay.
I could choose. So. Okay, Michael, thank you very much. The video, you will upload it?
Yes, yeah, this one is streaming. I see the stream going right now.
Okay.
Yep.
Okay. Thank you very much.
Thanks, Jan.
See you next week.
Right.
Bye-bye.
Bye.